name is Jacques Troussard, and welcome to my first game programming screencast for Computer Science 440. In this video, I will be walking you through my code, explaining some key aspects, and finally demonstrating the video game. The game we've been assigned to make is a type of guessing game. The goal is to successfully unscramble 5 different words within a 60-second time limit. With each correct answer given, the difficulty of the word, that is to say its length, should be increased. So let's begin by diving in and looking at the file structure. This is a fairly simple game. We're only talking about 3 files. Kind of logic, which is the internal mechanism of the game, gets everything working. It's accompanied by a header file, and then the source CPP, which is the main driver of the game. So in this game we need a dictionary. So in the resource files, this was the one provided to us as our kind of debugging dictionary, so we're not loading some giant thing every time. I have recycled a dictionary given to me from last semester. Coincidentally, it was for a C++, or data structures in C++, so I thought it would be appropriate to use it. It's quite large, 62,000 words, so it's plenty to work with. I did go through and kind of remove some entries that didn't make sense for this game. A lot of so pronouns I kind of got rid of because they just seemed too specific and strange. And then I went through by using Vim and some regex expressions, kind of cleaned up anything with kind of like foreign characters or dashes or any sort of punctuations, just so that that would just make the game seem unnatural in the game. So try to keep it as basic as possible, and that's my that's my working dictionary for the final game. That pretty much wraps up the structure of the game. Let's start going in, looking at the code now. What I'm going to do is run through the main driver here, the source file, and as we run into the methods and the components, I'll kind of refer back to logic and explain how they work internally. Okay, so let's get started here. We'll start with this source file. Take a look. These are just our standard includes. Obviously, we're going to need the Allegro library, our standard input-output library, and we're going to link in our logic file as well. Very first thing we need to start off with is this logic, making a logic object. So let's take a look at its constructor. So there's nothing fancy going on in here. We're just initializing a bunch of variables that are necessary to get the game rolling. We're keeping track of how many questions the player has answered correctly, how many they've attempted in all. Because in C++ there's no native way to keep track of the size of an array. We're going to do it manually with these variables here to prevent any sort of overflow issues. This boolean is going to control the flow of the game. We're just going to compare it to the number 5. Well, the number 5 is going to be compared to another variable, and once that 5 is met, this boolean will be flipped and will subsequently jump us out of a loop further on in the game. Here are the corresponding word pools. So as our easier words, the smaller ones are going to be put into this one, medium, and so on and so forth. Alright, so we have our logic set up. We're going to initialize our finished variable here to false because we haven't started the game yet. And timeout, this is going to be used further down in the threads. Now, I decided to be a little fancier with my file structure. I didn't want to just drop in my dictionaries into the root directory, so I made a subdirectory called assets, which was going to have to be included in the string when this Word file path is passed into the create list method, which is down here. So we just set up these threads, and then we're going to kind of get the game ready by reading in this file and creating the lists. If there are any problems, we just print to the console, and then in a C++ main suite, if they receive, if you return a -1, then we kind of we're canceling the game. So we open up a stream, we've passed in the file name. We're already sure, but I'm just double checking anyways whether the file can be opened. If not, we're printing this error message, and if we're successful, we're just telling the player, hey, listen, the game's loading, just give it a second. These flags here are meant to further accentuate whether the array is full or not, and I'm going to use them to break out of the while loop so that we're not processing the entire dictionary when our arrays are already full. So we just create this word variable. It's kind of like a current word, and it's going to be reused every pass. And we read it in, we measure its length, and then we insert it into its corresponding array. A small word being defined as being less than 5. And just to keep the game, so it's not silly, we made the word larger than 3. So if it falls in those criteria, it gets stuffed into this array, while it's less than 500. Here's our counter, measuring the size of the array so that we can prevent any overflow issues. This else statement here was more part of the debugging, and then also to kind of stop this while loop when we're all full. If we are done, if the flag has been tripped, let's go ahead and switch it to true, and then I had a little printout statement for myself letting me know that it had been done. So this is just copied over 2 more times, with the only changes being that the definition or the kind of criteria the word needs to match is shifted forward. In the very end, we're just taking a very simple concept of adding the sizes of each of the arrays. Once they equal 1500, we know we're totally full. We can just go ahead and return the value of true and break out of the while loop. If for any reason the dictionaries aren't full, or so the dictionary's been processed and we don't have enough words, or maybe another issue, it's gonna and the code has been allowed to progress to the bottom here, it just returns false, and we have it's kind of like an indicator that there were some issues going on. Alright, so now that we have our word pools properly set up, we can kind of get the game started as far as the player is concerned. So we're going to call this introduction method. So I'm going to explain that, and we can also get into my theme a little bit. Let's close that. Open up the introduction. So for my theme, I've chosen a kind of like a Mighty Python. When I was thinking about this whole word game, kind of it's like a silly scrambling the words, I thought of this scene in this movie, the Mighty Python and the Holy Grail, where Arthur and his knights are on the search for the Holy Grail, and in their adventures they're kind of stopped by this guard who's guarding a bridge, and he asks them all sorts of silly questions, and when they answer it incorrectly, they get thrown into this like the gorge of peril. So I kind of cheekily made a couple of modifications to it to kind of fit the theme here about unscrambling the words instead of answering velocity of a European swallow. It's done in this kind of screen or scripting format. We have the name and then their dialogue. These have been kind of intuitively or throttled with these sleep statements in between. So the longer this dialogue is, it's going to give you a little bit more time to read it, and then it moves on to the next one. I kind of wanted to make it feel like a small little play, or like a real introduction. So the knights realize that they have to answer these questions. No one's real sure if they want to be first, so we have a kind of awkward pause, and they all turn to look at you. So, and now we have like the official, the official rules of the game being given to the player. 60-second time limit, unscramble 5 words. We have unlimited failures. Then the player's prompted with this: when you're ready, go ahead and press the enter key. Good luck. I didn't want this to just zoom directly into the game, and the counter is clicking while you're trying to, still read the rules. So that's what this CN get line is for. Kind of waits for that return character and just gobbles it up. So this is more about taking a look at what the player has entered and whether he got it right or not, and then incrementing his points. So once he answers enough questions right, we increase the difficulty, or let's say the length of the word, and we can move on. And then obviously we're going to be also looking for that 5 here to flip that boolean to finish the game. So we're going to use this getter to get his current progress. While that number is not 5 and the timeout is not true, let's allow the player to make a guess. If this is the kind of game mechanism, returns true, that means that they've answered correctly. We're going to go ahead and give them a point. This add point goes back to this, like it's a setter for the number of correct. So it's not a setter in the most direct form, it's just an incrementer. So it's kind of poorly worded, or it's poorly categorized as a setter, but I felt that it was close enough to be in this group, so I left it in there. And regardless if they got it right or wrong, if this returns true or false, we want to record the attempt. So right outside this if statement, or the if suite here, we're going to add the add try, which is the same as the add point. We're just incrementing a different variable. Once we pop out of this while loop, we're just going to check and see if the player has won the game or not. If he's won it, we flip it to true, and then that will activate some things further in the main driver. If not, it's false, and we're just going to return null. So this thread can continue to be used. So that pretty much wraps up the threads. Alright, so this input thread called the play game method, which is really the heart of the game. So let's go ahead and take a look at that. So we're going to seed our random here with a very typical time-seeded random number generator. I've created this, which I've named here the random index, because it's going to determine which index we're going to pull out of those word pools, scramble, and then present to the player. So we're just going to call that random number generator. It's going to give us a number, and we'll take the mod of the size of the array so that we're getting a number that fits within the array. We're not calling 2,500, which would not be part of the array. But you have to be careful about this. Actually, I had put in a different number here, my math wrong, and it took me a minute to figure out what was going on. I was getting very strange results in my test because in C++, there's not kind of like a hard stop or a warning to this fault that you can make. So I was getting kind of like gobbledygook, and in fact, in some instances, it was pulling. It should have been pulling from this one, but the memory that was allocated for these arrays were close enough to each other where it was pulling from different lists. So I was I was confused at first for a few minutes trying to figure that one out. Anyway, so you got to mod it to make sure that you don't pick something outside of the array. And then the pick is what we're going to be passing into our scrambler. I really like switches, so this progress here is how many questions have been answered correctly by the player. So it starts off as 0. That case would tell the program to assign the pick variable to a random word from this small words pool. That would be the same case for 1, and then you answer more. Between 2 and 3, you're going to get a medium word, and once you have gotten to the last word, so we're going to call it like the boss word, you have the last opportunity here. We're going to take the challenging word from the large array. Once we have this word selected, we have to scramble it. So the game word is being set equal to this scrambled version of that word. Once we have the scrambled version of the word, we can prompt the user or the player to try and guess it. So we have to set a variable for their guess. We prompt the user, can you tell me what this word is? Give it a few spaces, word to guess, and then a little arrow there to signify, hey, start typing something. We pass that, and then we set that variable into guess, or we set that value into guess. And then, this is kind of computer science 201 stuff here. We're just do a very simple if-else statement. Hey, if it matches, put a kind of a cheeky reply here. You're not as dumb as you look. How about another? And we're returning to true. Now, if you remember, that's sitting inside here, this if statement. If you get the answer correct and it returns true, we're going to give them a point. So that's that return. Else, we're going to make fun of them. I wouldn't give up your day job. And then we return false, which would not increment their score, but increment their attempts once it comes out of the if statement. Alright, so that's the game mechanism. We can very briefly take a look at the word scrambler. This was just a matter of finding the right kind of pre-built method. So there's this thing called a random shuffler where, whoops, destroying my code there. Okay, so this random shuffle standard method, you just tell it where's the beginning part of the object, where's the end part of it, and then it does a bunch of swaps internally and returns a pre-scrambled result. So that's just pretty simple. Just as I said, it was just a matter of finding the right method to use. All right, let's get this thing going. The dictionary's been loaded, loading dictionary words into arrays. So these were kind of I thought these were kind of nice for the player to see, but they were kind of the headings to my debugging. It would go through and show me as the lists were being filled which ones got filled up. Okay, let me restart this. You don't miss the kind of theme. So we have scene 35, the word scrambler. Kind of set the scene. A small group of knights emerge from a cave. Before them stands a man gardening a bridge spanning a gorge. Arthur speaks. Bedemir replies. And then Arthur is kind of a goofy guy in this movie, so he keeps saying the wrong number and keeps getting corrected. So I probably should have entered or created some sort of mechanism to be able to skip all this, but this is sufficient. So who's going to answer the questions? We have our awkward pause. Oh, everyone's looking at you. Okay, so rules of the game. Another kind of description. The bridge guard is feeling generous, so you can miss as many as you want, but you must get the 5 within 60 seconds. And here they're just being kind of explicitly listed here. 60 seconds, time limit, unscramble 5 words, unlimited failures while time is going. When you're ready, press the enter key. So we're going to go ahead and do that. Okay, but is this? Prefers two F's maybe? Whatever. I don't give a good day job. This one looks like yeah, I'm really not good at this game, I can tell already. Oh, that's tour. There we go, we got one. Yeah, I don't know. Skip that one. LAM, dang. Yeah, this is a lot harder than you originally think. Really test this, especially when you've been coding for a few hours and you're getting tired. So I'm not doing very well at this game at all. Let's see. Oh, this is a sofa, I think. Oh, didn't even get it in time. But here we go. So I'm an indispensable servant. I tried 5 times. I only got 1 right, and then here's my little how I'll be remembered. So I feel like I need to redeem myself. I will give it another try here. So for testing purposes, I would just have for each scrambled word that was being presented to me right before it would have the answer. So I was just typing in the answers as they came up to test to make sure everything was running properly. Now, to do it without the cheat codes, I think it's a little bit more difficult. You got to be more alert and have a very strong vocabulary. So let's see what I can do this time. Giddy? Oh, whoops. That's my terrible typing there. Okay, this may be twine? That simple? Really? Extra? Okay, cool. Oh, yeah, okay, this is getting a lot more difficult here. What's going on? SH, maybe? Shiny? Oh, there's that. What am I going to do with that F? Okay, anyways. Yeah, no, I'm not going to do that one either. Neither that one. Slam orc? That looks like a word already. Slam orc. No, okay. Nope, don't want to do that one. Well, I'm a musical squire. So, anyways, yeah, I should probably listen to the advice and give myself to not give up my day job. But anyways, so that's pretty much the program and our presentation. I thank you for watching, and yeah, thanks for watching.